Assalamualaikum and hi. Today our group is going to present about application of differentiation. It is about related rates and also applied maximum and minimum problems. So to start our presentation, our group name is Jenny and our program code is CS110, course code MAT183, course group M3CS1102F. And this is our group members, which consists of 4 person. The first one is Nabil Farhan bin Azmi, which is me. Second one is Muhammad Ilmi bin Ismadi, Muhammad Jeff Aiman bin Harudin, and also Ahmad Yasin bin Kamaruddin. Our first topic for today is related rates. What is related rate? Related rate are problems that involve two or more quantities and their corresponding rates of change with respect to time. The relationship between these quantities is used to express their related rates in terms of the other quantities known as rate of change. So, for an example, we have a person. Uh, if a person grows up from 2 years old to 16 years old, for example, of course their height goes up. So there's this rate of height change. So we conclude it as dh over dt. And also, if we have the person growing up, their weight also will go up. So we have dw over dt. So for width and height, both of these are related. So it is interconnected and we can relate between each other. So to further explain about this topic, we are going to answer question one, which is going to be presented by Jeff.
Thank you very much, Nabil, for that brief explanation. Hello, I am Jeff Ayman. I will now explain how the concept will be applied in this question. So, as the question states, a straw is used to drink milkshake from a cylindrical cup. The cup's diameter is 8 centimeter. If the volume is decreasing at a rate of 2 centimeter cube per second, find the rate at which level of milkshake is decreasing. Now, uh, now from the question, we can get the radius of the cylindrical cup, which is we divide the diameter by 2 and we will get, so in this situation, 8 is divided by 2 and we will get 4 centimeter. And based on the question, it says that the volume is decreasing at a rate of 2 centimeter cube per second. So that gives us dV over dt equals to negative 2 centimeter cube per second. Why is it negative? Because it is decreasing. So now the question is asking us to find dH over dt. To do that, we must use the volume formula for the cylindrical shape, which is V equals to radius squared times height times pi. Volume in this situation, the radius is 4, so volume equals to 4 squared times height times pi, which will give us 16 h equals to height times pi. So now we will differentiate the volume formula, which will give us dv over dt equals to 16 pi dh over dt. Now we input the value of dv over dt, negative 2 equals to 16 pi dh over dt. dh over dt will be equals to negative 2 over 16 pi. dh over dt equals to negative 1 over 8 pi. So to conclude the question, the level of milkshake is decreasing is at a rate of negative 1 over 8 pi centimeter per second. Thank you very much, and now I'll pass the video to my colleague.
Moving on, for apply maximum and minimum value problems. The concept of apply maximum and minimum problems involves finding the highest or the lowest value of a function within the given constraint by using a concept called optimization. So there are many application problems in calculus involving functions to find maximum and minimum values. These problems are often used in various fields such as economics, physics, and engineering. Next, for our objective, it is used to maximize the profit in a company or minimize the cost to make a particular object. For the second objective, it is used to calculate the highest and lowest point of a curve in a graph or to know its turning point. For the next question, I will pass it to my friend Ilmi.
Hi, Assalamualaikum warahmatullahi wabarakatuh. So I'll explain question 2, apply maximum and minimum problems. Suppose that a manufacturing company wants to package its product in a closed can in the shape of the right circular cylinder. The merchandising department has determined that the volume of the can should be 16 centimeter cube. So A, show that the total surface area can be expressed as S equal to 2 pi r squared plus 32 over r. So, step 1, uh, S is 2 is S equal to 2 pi r squared H plus 32 over r. And the volume, formula of volume is pi r squared H, and the and 16 centimeter cube was given in the question. So, formula of area is 2 pi r squared plus 2 pi r H. Okay, step 2, we move pi r squared uh, at the right side. So, we get 16 over pi r squared. Okay. Uh, uh, to the next step, area is equal to 2 pi r squared plus 2 pi r h. So, we substitute the h with the value we got at 16 at at the top, which is 16 over pi r squared. So, after we solve it, we get the same expressions. So, the total surface area can be expressed as S equal to 2 pi r squared plus 32 over r. Okay, so we move to question B. Calculate the minimum surface area that can be produced. Okay, so firstly, we take the S equal to 2 pi r squared plus 32 over r. So, uh, we make it uh, to 2 pi r squared plus 32 r power, the power of negative 1. So, second step, we must differentiate it. So, it will be dA over dr equal to 4 pi r plus negative 32 over r squared. And then we will we will equal the equation to 0. After that, uh, we remove the r with the method, all of the equation we multiply with r squared. So, this will be 4 pi r cube minus 32 equals to 0. So, what we do next, what we do next is, we move the r to the right side, left side, and 4 pi to the left side, right side. Okay, and then we simplify, and then I'm sorry, and then we move the power of 3 into the right side, so it will be cube square. Cube square 32 over 4 pi. And then we simplify again and will be uh, cube root 8 over pi. And then the third, the third we we use we must do second derivative, which is the equals it equals 4 pi plus 64 over r cube. Okay, and then uh, we substitute the value of r, which is cube root 8 over pi, and then we solve, and we got 4 pi plus 64 pi over 8, and we solve again, and we get 12 pi, which is it is minimum because it's positive number. So, if it's positive number, it will be minimum. So, we put the value of the r into the equation s equal to 2 pi r squared plus 32 over r. So, r we substitute with the square cube root 8 over pi, and we got 24 cube root pi, or 35.150 to 1 centimeter cube. Thank you for watching.